Notable that this is the 60th edition, and twice a year, that means 30 years. So, and the price of entry to the list is now 1.73 petaflops.
The gathering momentum of Europe in HPC and the Leonardo system and the LUMI system kind of reflect an added investment, added emphasis of HPC in Europe, really putting a lot of investment and resources into their programs.
That's about 17 million times less.
The other thing, of course, is the continued momentum of AMD, especially among new entrants onto the list. It's quite dominant.
The number 500 back in 1993 was 0.42 gigaflops. We're also seeing PCIe networking that also promised to change the interconnect landscape.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hi, Shaheen. It's great to be with you again, as always.
Great to be here. Another special occasion.
Yeah, the new Top 500 list is out. Always focus of a lot of attention. Not a lot overly new with the list, but some very interesting developments. So what we have is Frontier, of course, is still number one and the only exascale system. Fugaku is number two. LUMI at number three, which is a HPE Cray system in Finland at one of their supercomputing centers. The only new entrant on the top 10 list is Leonardo, which is an Atos Bolsaquana system in Italy, in Bologna at the Cinema. Is that the correct?
Cineca.
Cineca, thank you.
Cineca is like cinema, but M replaced with a C.
That's it. Then the usual entries. We see Summit, Sierra, Sunway in China, Perlmutter, Selene, and Tiana. So we have two Chinese systems. But these are systems that have been on the list for several years. Nothing has changed. We're certainly seeing China really not playing top 500 anymore.
Yeah, that's too bad. I was noting as well that Tiani 2A is now number 10 at 61 petaflops. Those were big systems at their time. So I hope that they do come back and participate. Of course, there's a lot going on between China and the rest of the world and the West. And our last episode with Chris Miller drilled down into the chip wars.
Yeah, on the At HPC podcast now on our sites. It's funny, I think the whole increasing restrictions of U.S. exports of advanced chip technology to China, it's kind of a backdrop to SC22. It might not be talked about that much, but the microprocessors that drive supercomputing is right in the crosshairs, right in the middle of this international dispute.
There really is. And the reason why we keep coming back to this is because it is just so significant. It's impacting everything. But back to the top 500 list, Notable that this is the 60th edition.
Yes.
And twice a year, that means 30 years. So, and the price of entry to the list is now 1.73 petaflops.
Yes, that's the number 500 system.
That's the number 500 system. You go from 1.73 petaflops all the way to 1.02 exaflop. That's the scale that you see. Not exactly 1000x, but it's a pretty wide spectrum. So for laughs, I went to the June 1993 list.
Yes.
And the top computer on the June 93 list was 59.7 gigaflops. That's about 17 million times less. And it was a thinking machine CM5 at Los Alamos. The following three sites were also thinking machines. They had 5 systems all told on the top 10. NEC, their vector system, had 2. Intel Delta, one of the early massively parallel systems at Caltech, was on the list, and Cray YMP had 2 systems there. The number 500 back in 1993 was 0.42 gigaflops. And that was just a mere 4 million x less powerful than the number 15. So the stretch is more visible at the high end than it is at the low end, which also makes sense. So the frontiers, no pun intended, continue to outpace the rest of the pack.
Well, and certainly Frontier is so dominant, roughly 3 times the power of number 2 Fugaku. The only thing on the horizon that actually probably will displace it is Aurora, which is now being installed at Argonne National Lab. And I believe that's expected to be a 2 exaflop system.
Yeah, I listened to the video that you had with Rick Stevens and team, and very, very good video, by the way, really insightful.
Mm.
They were saying that they are not going to submit a number for this one. So in case you were wondering, stop wondering. but I sure hope that they are going to exceed. And of course, they built it to be 2 exaflops. So they should be able to do that.
Yeah. Another trend I think we're seeing, you've talked about for a long time on our podcast, is the gathering momentum of Europe in HPC. And the Leonardo system and the Lumi system kind of reflect an added investment, added emphasis of HPC in Europe, really putting a lot of investment and resources into their programs.
Right on. If you look at countries, the US stayed at 128 systems. China dropped a little bit from 173 to 162, but that's probably because they're not playing.
Mm-hmm.
But Europe exceeded expectations in my mind from 118 to 131 sites. So they are definitely investing. And along those lines, the other category in general is companies, the vendors themselves. And NVIDIA is unique in the sense that they have one system in the top 10, number 9, their Selene system, which is an in-house, obviously, Mellanox NVIDIA configuration that shows up very prominently at 63.4 petaflops.
Yeah. The other thing, of course, is the continued momentum of AMD, especially among new entrants onto the list. It's quite dominant.
No surprises there.
Not a surprise. We've been seeing that for quite a while.
Generally, like you were saying, in CPUs, AMD, GPUs, NVIDIA for now, but AMD is obviously showing prominently with their MI250 systems up in the top 10. And interconnects, Ethernet is the slow flood that keeps rising. Mm-hmm. And it's increased the number of systems from 226 to 233. So nearly half of the top 500 is Ethernet. The rest is substantially InfiniBand, 196 down slightly to 194. OmniPath slightly down from 40 to 36. But that area continues to be evolving really rapidly with the DPUs, NPU, XPU, whatever you want to call it, coming into the fray. They're going to impact the system architecture. And we're also seeing PCIe networking that also promise to change the interconnect landscape.
Yeah, on the composable side. On the Green 500, we could touch on that quickly. The number 1 system came in at number 405 on the list. It's a system called Henri, like as in the French Henry. Mm-hmm. And it's at the Flatiron Institute in New York City. It's, I believe, a Lenovo system.
Definitely. And then we go on to HPCG, the conjugate gradient. That was always sort of a lower bound of the kind of performance that you could achieve. And it's always been very important to me. I'm always reminding everybody of the quote that the great David Cook had mentioned, that the minimum performance of a system is arguably more important than the maximum performance of a system.
Yeah.
Because that's probably the neighborhood you're going to be with many of your applications. The 1 exaflop production application you just mentioned, notwithstanding.
Yeah.
So Fugaku is doing 16 HPCG petaflops compared to the 442 petaflops that it is doing for HPL. And Frontier is slightly behind it at 14 HPCG petaflops compared to 1,020 petaflops that it does for HPL. So it shows you again the range of what HPCG does to your application. It's just much harder application to get performance, and also a reminder of just how wonderful Fugaku is. Because as you know, I'm totally biased in favor of Fugaku.
And why is that?
I've said it before on this show. I think it's just a beautiful machine.
Yeah,
and I love the way it looks. I love the architecture. I love the strategy. And of course, it competes quite nicely with the GPU-based systems, and there's room for all of the above. But I am delighted that it exists, because I think without it, we'd have less diversity in system architecture.
Yeah. And why don't we finish up looking at what used to be called the HPL AI benchmark. It's now called HPL MXP, but it's really an AI-related benchmark.
It's really mixed precision, because AI says, I don't really need 64 bits. And they say, okay, Here's an application that doesn't need it.
Yeah. So Frontier came in number 1 at almost 8 exaflops, Lumi number 2 at 2, and then Fugaku at 2. There again, Frontier's power is just super impressive.
Yeah. Also, one thing to note is that 7.9 for mixed precision compared to 1.02 exaflops 64-bit, like you mentioned, is about an 8x improvement.
Mm-hmm.
Lumi is also based on the AMD MI250, so that's from zero point 0.3 exaflops to 2.2 exaflops.
Mm-hmm.
So that's also on the order of 7 or 8. And then Fugaku, of course, its own architecture, it's from 0.442 exaflops to 2, so it's more like 4 or 5x. But that's because just the architecture and maybe it not provisioned for as much mixed precision processing as the GPUs do now, and really everybody is going to.
Yeah.
So great list. Wonderful to have it. 30 years worth of data is priceless. And as you know, I'm a big proponent of this list and encourage everyone to participate so we can understand who's doing what and how much is being impacted by what configuration and advance our understanding.
I do want to just touch base again on Frontier. I think there's still a glow, if you
Yes.
will, around this achievement that first came on the scene on the June list. I wrote a piece recently about two of the Gordon Bell Prize nominees are groups of researchers using Frontier.
Uh-huh.
And they're just astounded at the performance. One of them is led by a researcher at Oak Ridge. He's working with other researchers at Georgia Tech and Cal Berkeley, I believe. And they're doing data mining. So it's using graph analytics to pool medical research, medical journal articles, research papers, scholarly papers, trying to draw new connections because the amount of medical information that's out there is beyond human ability to absorb. So while running their application, they exceeded an exaflop. This researcher said crossing an exaflops still feels a little surreal, even more so crossing an exaflops when doing actual useful science.
Yes.
It's an amazing state of affairs we've reached at the very high end.
It really is. It really is to get an exaflop on an actual production application. So kudos to the system and to them for making that happen.
Yes. All right. Great stuff, Shaheen. As always, great to be with you. And we'll talk again soon.
All right. Enjoy SC22, everybody. Talk to you soon.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.